Okay, welcome to our second online lab. This does replace our class meeting on the fifth week, Friday. So let's just get right into it. So this week we do have a lab handout, and you should read that before continuing with this video, because the video presentation really follows right from that handout. So that handout gives you just a quick overview of some of the farm payment history that we've talked about in class, and it ends with what are the 2018, so we have Farm Bill 2018, what are the ways that farmers can receive payments. And of course, the idea here is if any of you ever get into a career where you might need to understand how these are calculated, well, we have a lab here to do it. And then more generally, you understand how these sort of complex payments get calculated and what farmers, decision makers, are trying to deal with when trying to make plans, not just for production in terms of input purchases, but also how to what the planting and rotation is going to look like, but what can they expect the government assistance package to look like. The optional reading that this draws from, and you'll see some of the graphs from this this reading in the lab slides here, is another one of these Congressional Research Service reports. And it talks about commodity provisions, so the commodity payment provisions. There's the link to it that should work in your slides, and then the specific pages we are going to be using to get these calculations are 16 through 20, and then I think if you read pages 15 through maybe 21 or 22, you'll have basically everything in there in the reading that is about these two programs we're going to examine. Okay, so yeah, like I said, that lab handout really talks about the history of programs, and then gets to the fact that today's payments are based on historical base. So the idea that what you plant this year could influence the payment you receive is gone. It is really tied to some historical period where your production determined the allocation of your base acres. So if, let's say, between 2007 and 2012, I believe, for some farms, you basically had a 50-50 split between corn and soybeans, then that historical period may have been used to set your base acres, so that no matter what you plant today, if it's 2/3 corn and 1/3 soybeans, your base acres and the payments you receive are tied to that historical base from 10 years ago. Okay, so and that's just a way of keeping the sort of base separated from current decisions. So that's part of that decoupling of ag payments. And then, the second part of this is to come up with a formula that will increase payments when markets are in decline. Okay, so the primary purpose here is income support or price support. And so we need something that gets triggered when markets start to fall and keeps adding on support as the markets fall further. And we have a term for that. We call it countercyclical. So basically, it's the counter means against or opposed, right? And then cyclical just means in a cycle. And so if markets are cycling up, then we expect payments to be cycling down. Okay, so prices up, payments fall, and vice versa. Okay, so the two big countercyclical programs we have are called PLC and ARC, and the first one is the Price Loss Coverage Program. It's basically a price protection program. A target price is set, and when the market falls below that target price, the payments get triggered, and then however big that difference between the target price and the market price is going to be how the payment is set. And so we'll see how that works in our lab calculation. The second program is called Agricultural Risk Coverage, and it takes on an additional component. And so the reason it's called risk coverage is because there are two major uncertainties that exist for farm income. over the course of the planting season from plant to harvest. And that's the price that you actually get, which will come from the market, and the yield, which will be determined by any number of factors, both inside and outside of the decision maker's control. And so it becomes this revenue protection program. So revenue is price times yield, and what happens is the county, each county has a target revenue set, and we'll see how that's calculated. That target revenue is sort of the protected revenue level. I think it's called the revenue guarantee. And when county revenue, the actual sort of, after we've realized what the yield in the county is going to look like on average and the price is going to be nationally, then the county revenue falls below that target or that guarantee revenue level. The payment gets triggered, and again, the size of that difference, how deep does the actual revenue fall below the target or the guarantee, that will determine the payment. Okay, so that optional reading has these graphs, which are actually not too bad. They look more complicated than they are, for each of these payments. And so Figure 3 in the optional reading says the price loss coverage formula, and it breaks it out sort of schematically here. And so remember, the PLC is price loss coverage here, and it's a comparison of a target price and the actual price, or the farm price. And so the comparison of those two prices is going to determine first if you get a payment, and then the gap between those two is going to determine how high the payment will be. Okay, and so the first part here is sort of calculating that target price or that reference price, and that's what this box here is telling you about. So we have the PLC effective reference price on this side of the green line, and that will be the larger of either what is set by the statute. You guys have already looked this up in your homework for several different crops, and so we know for corn that reference price is $3.70. But it could be that the price that was set by Congress when they were writing the law isn't high enough, and so it could be that the protected price is actually going to be something different, and in fact it's going to be based on a moving average of the marketing year price. And so this stands for 5-year Olympic average marketing year average price. I know that sounds like a lot, and it actually is, but we're going to calculate it in the lab and you'll see. But basically it says, what is the price, the statutory price for corn is $3.70. If the last 5 years prices have been at $4.50 every year, or between $4.50 and $5.25, then that statutory price is irrelevant. Nobody's ever going to be in PLC because it doesn't actually offer any price protection. So as corn prices stabilize at $4.50 or something larger than the statutory price, well, input prices move up, right? We pay more because there's more value in the crop production. There's more demand for the input needs to make an acre of corn. And so the statutory price goes out of date. And so this this Olympic average 5-year tracking of prices is meant to keep the statutory price from being out of date. And so instead you could be 85% of the Olympic average price for 5 years. An Olympic average just means take away the largest value and the smallest value and calculate the average of what's left. Okay, and so basically what we're going to do is we're going to look at 5 years worth of prices that precede us. We will calculate the average of the 3 remaining prices when we throw away the largest and smallest value to get the Olympic average, and then we're going to calculate 85% of that, and that'll be our protected price level. And then we have one final thing to check. It has a cap. So you get the larger of these two, but only if the larger of those two is no bigger than 115% of the statutory price. So if it's $3.70, take 1.15 times $3.70 is what we're going to do in the lab. And it doesn't matter if this value, this Olympic average, comes in higher than that, you still only get the 115%. That is the complication that we have to deal with. So, the thing we want to imagine, or the thing we want to be prepared for is, if you're a farmer, it could very much look like the government is creating a program where there's so much sort of junk to get through here that they really want you to just give up and not do this program, or to just do what or to have no idea, right, what the payment is going to be. And so, that's not sufficient. So we want to be prepared to educate people. We want to be prepared to understand them ourselves. And so we're going to build a spreadsheet that lets us calculate that and sort of sort through that. And maybe even understand, we'll talk about in class after we've done this lab, why is this set the way it is. Okay, that's the reference price or the target. And then over here we just have the farm price. So the farm price is just going to be the larger of the marketing year price or the loan rate. And you've looked up the loan rates as well for your, I think it was homework 3. And you saw the loan rate was like $2.20 for corn. So it's quite low, but that's the absolute floor under the prices. And so whatever the national year price is going to be gets compared to this target. And if there is a difference between the reference price and the marketing year price, you will start to get a payment, and the payment will be calculated as such. Okay, so figure 4 gives the rundown here. It says, what if prices are low for rice? First step, the PLC effective reference price, or the target price. The statute says $14. 85% of the 5-year Olympic average is just going to be $10.91. So that means we're going to use $14. It's the higher of those two. And since we're using that, we know we're not above the cap. The farm price is going to be $12.20. That's just an assumption, or a low price scenario that's being considered. And so the PLC payment rate through all this noise just ends up being 14 minus 12.20, $1.80 per hundredweight. And then based on whatever they made up some assumptions here on what the base acres are and the program yield for this farm is, and then there's a final 85% calculation because you only get farm payment coverage on 85% of your base acres, and that's what that is. So that's the PLC payment. That is what we call price loss coverage. The idea, you get a target price, which takes into account of a lot of information. It gets compared to the national price, not the price you receive on the farm. Right? So if you're a good marketer and you consistently beat the marketing your average price, then you're going to get not only sort of the benefits of your strong marketing, but also the benefits of the national program that offers price protection. Okay, and so here's the second part. So walking through that in terms of words, if we were going to do the corn example, we would need to find the effective reference price for corn. So $3.70 is what's written into the law for corn. The moving average reference price that we compare that to, we get the larger of 1 and 2, would be take the last 5 years, drop the highest corn price, the lowest corn price, multiply it by 0.85, and then finally we would need to take 1.15 times $3.70, and then the comparison we have to make to get the reference price is take the larger of these two, as long as that's not larger than 3, then we use the larger of 1 and 2. Find the farm price, we just look at the national marketing year price. As long as that's bigger than $2.20 for corn, that is what we're going to be using. Part 2, take the difference in those two. If it's negative, then you don't get a payment, right? If the marketing price is above the effective reference price, you don't get anything. But if it's positive, if there is a gap, then you get, based on your base acres, your yield. That's a historical production record. So that program yield is set farm by farm, and it's based on, again, some historical level of production that you had and put on record so that the yield you attain today doesn't have any effect on what the basis for your payments are. And then you get the total PLC for the crop. Okay, so let's take this chance to jump over to our spreadsheet, and so I'm going to pause and switch over and open your spreadsheet, and we'll do some calculations and fill in our first sheet on the PLC program. I actually jumped out too quick there. We need to do one other thing and think of the Excel tools. So one quick introduction to Excel tools that we should consider before we get into our spreadsheet is the if function. You may have seen it, certainly if you've had AGEC 202, I believe it is, the spreadsheet tools class, you would have used it before. But let's refresh ourselves. And it's just used for conditional assignments. Basically says there's a condition, let's just call it A, and if that condition holds true, then you tell Excel to enter some value X in a cell, and then usually matched up with if is else or otherwise. If that is not true, right, enter Y into the cell. And so the way that it looks in Excel is just going to be, it's a formula, so it goes equals if, and then you open up a set of brackets, and the first thing that has to be entered is the condition. The second thing after the comma is the value to assign to that cell if the condition is true, and then the third thing to assign, the third thing listed after the second comma is the value of false. Close off the brackets, and that spreadsheet will consistently do that evaluation for you and give you the correct assignments. Okay, so open up hopefully you downloaded the spreadsheet, and you can open it up now. And we're going to use the PLC Payment tab or sheet, I guess, as part of this workbook. And we're going to go through and fill in all the formulas that we would need to calculate a PLC payment, or to build, I guess would be a better description, build ourselves a PLC payment calculator. And I say that because you should be able to, if we do a good job, we should be able to make a spreadsheet that we could use even as conditions change. So you'll see I've got some things marked in yellow and some things marked in green, and that's because for the yellow things are fixed. They should not be touched, right? So the yellow is like the warning thing. But green are things that might change, right? We don't know the actual marketing year price for corn yet in 2019. The marketing year goes all the way till October. So 385 is just what the current forecast is, and we're just saying the PLC yield for some farm is 165 and that the base acre is 120, but those could be those will change from farm to farm. And so the green things are things we could actually adjust, and we'll actually mess around with those a little bit. But now we have all these rows where there's nothing. We need to introduce a formula. And so let's start with the simplest one. If we remember back to the slides, there was a cap on what the PLC effective price could be, and it was 1.15 or 115% of this value, the reference price. So that's an easy formula for us to get down and get started with. So let's go with equals 1.15 multiplied by that cell B2, and so 426. So we know that for corn, because the reference price in the statute is 370, the price protection will never be larger than 426. The more difficult one is this Olympic average price. Okay, so 5-year Olympic average, marketing year average price, and then 85% of that value. Well, it turns out we need some historical data for that, and down here at the bottom I have prices, marketing year average prices going back to 2013. So for 2019, the prices used are from 2017 to 2013, so there's a 1-year lag. So the 5-year price average goes from 2017 back to 2013 for calculating 2019 payments. Going ahead 1 year to 2020, you will pick up the year 2018 and drop off the year 2013, so that the next year for 2020 would use these 5 payments, or sorry, these 5 prices. So what do we need here? We need a price average that calculates the average of the 3 middle values down here. So drop the highest value, drop the lowest value, these two will be tied, and take the average of what's left. And so we need an Excel formula that will do that. And it turns out there isn't one. That it takes a whole bunch of formulas. So let's go through and see if we can type this thing in. So the first part of this is that we know we have to multiply by 0.85 because it's only 85% of that Olympic average. The second part is that we know we're only going to use 3 of the 5 prices, so we need to divide by 3 to get an average. So let's just go with 0.85 divided by 3 multiplied by, and then I'm going to start a parenthesis. And so we're basically taking, because of this 1 over 3 right here, we're going to say I want inside of these parentheses to be a sum. Sorry, looks like you can't close the parentheses until you have a complete one. I want to put in the price sum between 2013 and 2017, but have it remove the largest value and the smallest value. So it turns out Excel actually knows how to do that. So let's go with the sum. That's a formula in Excel. You type the open parentheses and you can go down here and collect 2013 through 2017. So it's going to show up as B19 to B23. Okay, so we've got the 5 values. Now we need to find a way to get rid of the largest and the smallest, and it turns out Excel has formulas called large and small. So I'm going to go minus large, open parentheses, and you can see here it's saying give me the array and then K. And so what it's asking for here is give me the values you want compared, and then which value do you want taken away, or do you want to choose the largest first, and if you put a 2 in place of the K, you would get the second largest. If you put a 3, you would get the middle one, and we want the largest one. So let's go with large, select all 5 of our values again, 2013 to 2017. So that's going to be B19, B23 again, comma, and then 1. We want the first largest one, the one in first place. Now, because the large lets you pick the rank, we could also do the second one being minus large B19, B23, and then put a 5 there. But Excel has the other formula as well, so let's just do small. So small is the same thing, and then you can read the description here. It says returns the kth smallest value in a data set. So for example, the 5th smallest number, we want the first smallest number. So let's open parentheses, select our 5 values one final time, go back up here, B19 to B23, comma, 1, close the parentheses. And so we have add up all 5 numbers, subtract the largest, subtract the smallest, and then multiply them by that. And let's just close finally the parentheses. Right, you have to match up that parenthesis there that says what you're multiplying and the one here that closes off that value, and hit enter. I'll leave it there so you don't have to, but you can also pause the video if you want to be sure you get that right, and you get 302. Okay, so if you want to check that, you could go down here and say equals this plus this plus this, 1067 equals this divided by 3 equals 356, and then finally 0.85 times that value, 302. And so it looks like our formula gave us the right thing, and we did it step by step here. We added all 5 up, or sorry, we added the 3 middle ones up, divided by 3, multiplied by 0.85. Okay, so we got a formula here that works. Now we have everything we need. We have $4.26 is the cap price, 370 is the reference price, 302 is that Olympic average price. Okay, that price that we're using historical or sort of recent price history to give us an idea of whether the statutory reference price is out of date or not. And so it looks like it's still in play. We have a farm price prediction of 385. What we need though is to select which of these will be chosen. We know it's going to be 370, but we need a formula that will return to us 370. Okay, so remember the rules on this one. It's $3.70 versus 302. It's compared to these first two. Take the bigger value, and as long as that bigger value is less than this, that'll be the effective PLC price. If the bigger value of these two is larger than 426, then it needs to be 426. And so let's make a formula that does all of that comparison, and this is where we'll use our if statement. So if, that means we want the larger of 370 and 302, and there's a formula in Excel that will do that. It's just take the max, open parenthesis, compare these two, give me the largest one. And so what we're saying is if that maximum of these two is less than this value, that's the condition now. So take the largest of these two, compare it to this value. If that is true, and it is less than those, then use the maximum of those two. Close the parentheses. That's the, okay, so we got the condition, take the max, compare it to B4. If that is less than B4, then truly we want that to be the value that gets placed there. And if it's not, the condition for when it's false, just use B4. Okay? Close that, and we know it should say 370 when we finish. And that's what we have. So we have 370, 302, 426, 370 being the surviving value as the effective price. 385 is our predicted farm price for 2014. Down here we have some extra values: PLC yield, PLC base acres, and then this multiplier. And so if we wanted to calculate the PLC payment, we would need to calculate the effective price compared to the farm price. Oh, sorry, we have this formula first. So the PLC payment per base acre per bushel is given right here. And so if we wanted to get this on a per bushel price, then all we need to do is do that calculation where we take 85% of the difference between these two values, but only if the effective PLC price is larger than the farm price. Okay, so we know it's going to be 0, but we need to actually do the calculation, so let's go through. We'll go 0.85, that's the 85% reduction for the base acres, times, and we're going to need one more if statement. So if, open parentheses, B7, this, the actual farm price is less than the effective PLC price, right? So if that difference is positive, then what do you get? Well, 85% of the effective price minus the farm price. Okay? So here's the target, here's the actual price. So as long as the actual price is below the target, then you get the target minus the actual price. And if that value is not true, remember, it's if this condition, you get this value, and if that's not true, you get 0. There's no payment. Then we need one parenthesis to close off the if statement, one additional parenthesis to close off because we did multiplication times a collection of items, and then we just hit enter, and we should see what? 0. Because 385 is larger than 370, and now we can test this right away by putting in something like 350. And we see at 350, this is smaller than this. You get 17 cents, and it doesn't take too much to understand that that difference is 20 cents and 85% of that difference is 17 cents. Okay, let's go with 385. Okay, and then down here we have some different versions of the PLC payment that we can calculate. So I left the 0.85 here. We could have used that multiplier in place of this. So instead of using 0.85, just typing it, it would have probably been better if I'd have used a formula. I'm not sure why I didn't, but my notes don't have me doing that. So let's leave it like that. But we'll have to be careful when we come down here and calculate the PLC payment. So for the PLC payment, we have B9 being the payment per base acre per bushel, and we're not going to use this value when we calculate it. So we know the payment per base acre per bushel. That means that when we want the PLC payment, all we really need to do is multiply this value times this value times this value, right? That's what per and per mean. You get the total by multiplying those. So let's go with B9 times the yield, right? So we get it for every bushel of the base of the historical yield, and then we get it for every base acre. We've already taken into account the 0.85 when we calculated that per bushel payment. So we have that. And of course it's 0, and now we need because the per unit value is 0, and then the PLC payment per acre would just be equal to the total payment divided by the total base acres, and also going to be 0. Okay, let's ignore all that for a second. Okay, so we've got up here a price per bushel per acre, down here a total, down here a total per acre. We can see it every way we want, and we know that if we put 350 there, we get actual payments, so that we see it's 17 cents per bushel per acre. Down here, the total PLC payment for a 120 acre farm, $33.66, and then the payment per acre is 28. Okay, so that says 17 times 165 times 120 gives you this. Okay, that's our PLC payment. That's the easier one, or I suspect. And it's the only one we're going to fill in on this one. Your lab spreadsheet will already have the ARC payment and the second one filled in. So let's go back to our slides. We've calculated the PLC payment, and the ARC payment is going to be pretty much the same, except it's going to have a second component, a yield component. Okay, we're back with our ARC payments now. The second one, and we're going to go through this one, and then we'll look at it in the spreadsheet, but that spreadsheet is already completed for you. And then we'll see how we might compare these two. So the first thing here, these are the figures from the reading 5 and 6. And so the basics of this ag risk coverage formula is that you're going to compare a guaranteed revenue for the county against the actual county revenue. And then every base acre in the county gets a payment based off of that comparison. Okay, so we have level 1, calculate the benchmark revenue. So we now have already done a spreadsheet where we calculated Olympic average national price, and Olympic average county yield works the same way. So the Olympic average national price is going to look just like we calculated for PLC. The Olympic average county yield means that we need a county yield record for every crop for 5 years. And you'll see in the spreadsheet that we have that. I think the Tippecanoe County yields are the ones we use. You calculate those two values, multiply them, and then the county revenue guarantee is just taking 86% of this value. So this tall green box is called the benchmark revenue. Take 86% of that. That's the value that's guaranteed, or that's the target is set at 86% of that historical value. And So take those two, multiply them, multiply by 86, and you get your guarantee. And then for the actual county revenue, you take the national price for the year times the average county yield. It's actually calculated. Compare those two. If the county revenue guarantee is larger, right? If this value is larger than the county revenue, then you trigger a farm payment and you calculate it again based on base acres, and restricting those, you only get paid on 85% of the base acres. Okay, so over here we have the county low revenue scenario for corn. $3.70 being the reference price. So you either get the reference price or you get the 5-year national price. So it's $3.70 times 150 being the bushels per acre for this example county. That makes the benchmark revenue, this full column, $555. When you take 86% of that to get the benchmark, or sorry, the county revenue guarantee, the number becomes $477. Then for the actual county revenue, you take $3.50 times 125 bushels being the county yield for that year. You get $438 being the actual revenue compared to $477. Take the difference. $477 minus $438 is $39, and do the calculation. So let's jump back to the spreadsheet. I'll get the right version here and open up the second sheet. We filled in this one. This one will show up already filled in for you, and you see that I've calculated a bunch of the same sort of things that we did before. So the 5-year Olympic average price, $356. If you double click on that, you'll see we're using those same 5 prices as before. We're doing a sum, and then the small, and then the large. That gets compared to the PLC price of $3.70. And so the Ark County guarantee price is going to be the larger of these two. So we just take the maximum of B3 compared to B2. And now we need to calculate the yield, because the ARC program is different in that it's a revenue program. And so for the ARC yield, we need to calculate for 5 years, 2013, the same 5 years as the price, what is the county yield average. It turns out it's a trend adjusted yield, so that's why these are in italics, but take the Olympic average of these 5 yields. Okay, so if you look at this formula here for the ARC program yield, it is 1/3 times the sum of the 5 minus the smallest of the 5 minus the largest of the 5. You get 204.23 being the average yield. Multiply the county, the ARC price times the ARC yield, you get the benchmark revenue. The guarantee revenue is going to be $649.87. Okay, and that's just 86% multiplied by the benchmark revenue. So the 0.86 came right off the slide. The slide we saw, the rules, and then B6 is that value. Okay, what do we compare that to? Well, we need to know the actual county revenue, and so just for simulation's sake, I think the county yield prediction right now for 2019 for Tippecanoe County was 203, and the predicted price for the national corn price for 2019 marketing year is 385. That would give you an actual county revenue of 781.55. Okay, so we tested a value of $3.50, I think, in the other spreadsheet, the PLC spreadsheet, and so if we do that now, we can see that the actual county revenue falls to 310, and we still don't trigger a payment. So we could actually lower this to something like 275, and you see that then you get the actual revenue below the guarantee revenue and you trigger a payment. Okay, so these kind of simulations, or these kind of changing of the assumptions, is an important part of this. And so that gets us back to our slideshow for the last comparison that I want to, the last sort of Excel tool I want to introduce you to as part of this lab. So let me jump back. okay, to the second part here, and it's called a data table. So, we were doing our spreadsheets, PLC, we had to fill that one in. ARC was already filled in for you, but it's interesting enough to say, okay, the price is $3.85, and here is a situation where we don't get any payments for corn. But what if the price is lower? What if it is different, right? And so if you had to choose which program you want to be a part of, then comparing a situation where neither one of the programs pays out isn't that interesting. But comparing sort of low price conditions and seeing which program offers or how they differ in offering you protection versus on revenue side versus price side could be important, and that's what we want to do with these spreadsheets now. So what we're going to do is use the data table function. It basically takes a table of values and says what are the things that you want to make adjustments to, like in our case prices, and let you look at a series of prices and calculates for you over and over what the formula would be. In this case, what would the payment be if the price was not $3.85 but $3.50, $3.25, $3? And so we want to not have to keep plugging in values in our spreadsheet and recording all those. We want it all done at once, and that's what the data table does. It's under a section of Excel called What If Analysis, and essentially it says, what if the price doesn't end up being $3.85 but it's $3.15? Well, we could have that as part of our data table, and we'd be able to compare both the programs. So let's go back to the spreadsheet. You can see I have the setup already there, and see what we can do. Okay, so you're welcome to go to the help in Excel. I say that when I can't find it now. If you go here and type help, it'll open help and you can look up the data table. But for us, let's just look. It's going to be under this part called What If Analysis. And so if you click on that, you'll see that you get results for different inputs being introduced into formulas. And so the way we set this up is to use the rows for one assumption and the columns for another assumption, and then at the intersection here it's going to calculate for us whatever payment we want calculated. And so the payment we have calculated down here is the ARC county rate per acre, and so that seems like a good enough value to calculate. For us. And so what we do is we just put up here, we go let that corner of this table be equal to that formula. Okay, and you can see what it did was I've already done the data table here, and so what it does is it fills in the formula. In this case, if $2.75 is the price assumption, and from right here, and 190 is the yield assumption from right here, then the payment is going to be $127 per acre. Okay, and so we should probably actually that's the payment rate, and then 85% of that. We only get paid on 85% of the base acres, so that is not introduced there. So that is the data table, and if I delete it, this stuff, then you can see how to set it up, and I will show you. So if you go here and then highlight everything, all of the intersections, and drop down and click data table, it gives you two things it would like you to give as inputs. So the first thing is there's a row of information here. Where do I go in the spreadsheet and look for that value? And so for the row, this row of stuff is based on the yield. And then for the column, where is this information? Well, that's the actual price. You click there, and once you click OK, it'll reintroduce all those values. Okay, And so it's basically saying as prices go up, payments go down. And then if you look across this way, as yields go up, as prices go up, the payment falls for any yield, but as yield goes up for any price, the payment is going to fall as well. Okay, go back to the PLC. What are we going to look for here? Payment per acre, or we could look at the payment per bushel if we want. So let's just do that one. So if we have this, we get the payment per bushel, and you can see it already filled it in because it knows what's going on. I've already introduced that one, and so your table should be filled in for you. The key thing here was telling it which formula it needs to use. And so if you are a farm that has 165 PLC yield and the actual price during the year shows up as $3.25, you get a 38-cent payment per bushel, adjusted for the base acres. Okay, and then we could also make a new table that points to the payment per acre, or we can make a new table that points to the total farms PLC payment, just however we want to make it. This corner, whatever we link it to, it'll use these assumptions, the yield assumption and the price. Now, I didn't put a column over here where a bunch of other yields are considered, because for any given farm, this yield is going to be fixed. It's a historical yield. And so another farm may need a different assumption here, but it's not going to be able to calculate multiple assumptions. That's not true for the ARC payment. These are the yields for the county in the current year, and so that's what the difference in those two are. Okay, so this is a lot. We're going to keep playing with this a little bit in class, but you have a few quiz questions that you can, I think some of them ask you to look in the formulas that we were given on the ARC sheet. So you'll have to open up the formula and choose which answer is the best explanation for it, and then I believe you have to complete a few alternative calculations here, make some changes to the assumptions, basically changing the green values, and then choose the right outcome, basically as sort of proof that you completed the lab. And so with that, we're almost at our 50-minute time limit for this class, and yeah, so I think you're ready to move on to the quiz, and we'll have some basis for talking about these things as we move forward. How do these two programs differ? And basically what we want to think about as we compare them in class and some other programs that have fallen by the wayside, where do they fit in the farm policy goals? Do they only do price and income support? Is there something about these payments, or if we added something to these payment calculations, would they have that family farm survival aspect, or helping farmers choose, allowing farmers to respond to markets, and so forth? So that's what we want to talk about in context of these payments, as well as some others going forward. And now you know how these things are calculated.